You ever see one of those massive, multi-billion-dollar projects and just wonder how it could fail so completely? Well, it's almost never some random act of nature. Today, we're going to dig into a hidden truth, one that starts not with an explosion, but usually with a quiet little mouse click in an office.
And that's really the heart of it, isn't it? This isn't stuff you learn from a textbook. The wisdom we're about to get into was paid for with some incredibly expensive mistakes. The kind that stick with you, the kind that wake you up in a cold sweat. But they also teach you the most important lessons.
So, where does a catastrophe like this even begin? Forget about the dramatic stuff, the landslides or the floods you see on the news. The real disaster, it usually starts in a nice, comfy office chair, with a decision that seems to make perfect sense at the time.
There's actually a name for this problem: contextual arrogance. It's this incredibly tempting idea that a perfect 3D model on your computer can just be, well, dropped anywhere on the planet. But here's the thing: a beautiful, shiny digital drawing has no idea if it's in the middle of Canada or the middle of the jungle.
Let me give you a real-world example of this arrogance in action. So, picture this: a huge copper-gold project. The engineers, they took a proven, really successful water treatment design from a project in Canada, and they literally just copy-pasted it for a new site in the tropics. I mean, what could possibly go wrong, right?
Okay, in this slide, this is where it all falls apart. On the left, you've got the design's assumption. Nice, low, manageable levels of silt, just like in Canada. But on the right, you have the tropical reality. The rainy season hits, and the silt levels don't just go up, they triple. Those perfectly optimized pumps, they were never, ever built to handle that kind of abuse.
And the result of that mismatch is, well, it's pretty brutal. The pumps didn't just break down or get clogged. They were literally torn apart, eaten alive by all that sediment. A critical system in a billion-dollar project was just completely destroyed. So you've gone from a perfect-looking design on a screen to a total catastrophe on the ground. This is the moment a project enters a special kind of crisis mode, a state of chaos so common that industry veterans actually have a name for it.
They call it the treble. It's that perfect storm where absolutely everything goes wrong all at once. You're not just missing one target, you're missing all of them. You're hemorrhaging money, the schedule is a total fantasy, and the technology itself, the core of the project, is just broken. It's this downward spiral that feels impossible to get out of.
And of course, a technical crisis like that immediately turns into a human one. The boardroom gets toxic fast. The contractor starts blaming the engineer blames the environmental team, trust just completely dissolves, and all that forward progress, it grinds to a dead stop.
So how in the world do you pull a project back from a total nosedive like that? It's not like you can just hit the undo button. When the pressure's on, you have to stop the bleeding and get back in control. And that's where something called engineering triage comes in.
I mean, imagine this for a second. You're high up in the Andes Mountains. Concrete is literally being poured for these massive crusher foundations. And then it hits you. That stomach drop moment when you realize the designs weren't rated for the local seismic activity. You have to act, and you have to act now. So what's the playbook for a moment like that? Well, it boils down to these 3 steps. First, you isolate the problem. You don't shut the whole site down, you keep other parts moving. Second, you have to be radically transparent with the client. No hiding, no sugarcoating. And third, and this is the big one, you bring them a recovery plan. This right here, this is the absolute golden rule of managing a crisis. Anybody can walk into a boardroom and announce a disaster. That just creates panic. But walking in with the problem and a solution and a cost and a new timeline, that shows leadership. That turns you from the guy with a problem into the person with the solution. Now, that whole copy-paste mistake we talked about, it's still a risk, but it's evolving. Today, the danger looks a little different, and it's a special kind of challenge for the new digital generation of engineers. Look, today's young engineers are brilliant. They're absolute wizards with this incredibly complex design software. But that skill creates a brand new kind of vulnerability. They trust the software, maybe a little too much.
And here's why that's so dangerous. The software, you see, it's a yes man. If you tell the ground is solid rock, it will design you a perfect foundation for solid rock. It won't argue. But if the reality out in the field is that the rock is actually fractured, unstable shale, well, your perfect design is built on a complete lie.
So this all leads to the big question, right? If all the best experience comes from making mistakes and the software can't always be trusted, what's the single most important piece of advice to avoid these kinds of disasters from happening again?
It's just 3 words. Seek out the mud. It's so much more than advice, really. It's a whole philosophy. It's all about closing that dangerous gap between the clean, perfect digital world and the messy, unpredictable real one.
But what does that really mean, in practice? It means you have to intentionally go put yourself in the difficult, dirty, real-world places where your designs will actually live or die.
You see, getting your boots dirty, it teaches you things a computer screen never, ever will. You see with your own eyes just how hard it is to build the thing you drew. You start designing for the guy who's actually holding the wrench, not just for your laptop. You learn a kind of resourcefulness you can't get from a book because on a remote site, you can't just Amazon Prime a spare part. You learn to plan for reality.
And that brings us to the golden rule that ties this whole thing together. It's about humility. You have to respect the physical reality of the place you're trying to build. You just have to. Because you know what? At the end of the day, the ground you're building on doesn't care about your schedule. It doesn't care about your budget, and it definitely doesn't care how beautiful your 3D model looks. Reality will always win. You either adapt to it or it will break your plan. Every single time.
So what's the one thing to take away from all this? It's simple. Get out of the office, verify the ground for yourself, talk to the people who actually have to build and operate what you design, and always, always keep your boots dirty. It's the best insurance policy you'll ever have.